Good day, and welcome to Zoyols News. I'm Michael Reed. Researchers at MIT have introduced an innovative robot capable of both flying through the air and moving underwater, marking a significant step forward in robotics. The breakthrough could open the door to new applications in search and rescue, environmental monitoring, and scientific research. I'm Michael Reed. The news begins now. The team of aero-aquatic roboticists looked at petrels, puffins and other diving birds that use their wings to propel them through air and water, and studied the dynamics of transitioning between the two. Raphael Zufari said no one had previously turned this into a fully moving robot. They mapped wingbeat frequencies across species and designed a 250-gram flapping aerial aquatic vehicle powered by a battery motor, with nylon wings and a tail coated in water-repellent nanoparticles. Zufari stressed the FAAV is not simple biomimicry because water is far denser than air. Diving birds partially fold their wings underwater to reduce amplitude and drag, but duplicating that would add joints, complexity and weight. Instead, the team built a non-folding wing that is more flexible than a bird's to keep amplitude low. The FAAV doesn't detect whether it's in water or air. It simply targets a programmed wingbeat frequency. It can fly just over 6 meters per second and swim nearly 1 meter per second, with theoretical ranges of 6 kilometers flying or 2 kilometers swimming per charge. After a year of testing in a Massachusetts tank and later Lake Geneva, the team fine-tuned dive entry and water exit angles. In mild waves and wind, the robot can operate, though rough conditions are still a limit. National Oceanography Center engineer Madan Furlong called the dual air and water design a major technical achievement. The lab is now seeking funding to combine flying, swimming, transitioning and diving into a single autonomous mission. Zufari said the team can fly, swim, transition and dive, but not yet in one fully autonomous run. He argues a cheap, lightweight aerial aquatic vehicle could lower the cost of ocean sampling by flying set routes and diving for samples. Potential uses include sampling toxic algae blooms, volcano lakes, and areas near icebergs, plus wildlife monitoring with cameras. Furlong raised questions about payload capacity, robustness, regulatory approval and real-world open ocean operation. He noted combined aerial and underwater vehicles are rare because they're hard to build and their advantages aren't yet proven. He also pointed out that efficient propellers and electric motors are tough to beat on cost and practicality, though he didn't dismiss flapping robots for ocean research. Furlong said ocean scientists care most about reliable, cost-effective, high-quality data, regardless of how it's collected. If the platform proves those traits, it could be adopted. Zufari says the design could scale to a 15-meter wingspan, costs about $300 in parts today, and could stay under $1,000 even with upgrades. He's also set up a new MIT lab with a larger tank for continued testing. That is the latest on MIT's new robot capable of flying and swimming. As researchers continue testing its real-world capabilities, we'll keep you updated on how this technology could shape the future of robotics and innovation. For more breaking news, technology updates, and in-depth coverage, stay with Zoyols News. I'm Michael Reed. Thanks for watching.